First one, which binomial is a factor of both? So we're essentially just factoring both these expressions and seeing which out of that list is part of both of them. These are all called binomials, means two terms. So each of those have an x and a constant. Excuse me. Anyway, so remember factoring? We'll do the x squared minus 8x plus 15 first, just because it's easier. But your first step is to look for a GCF, meaning can you divide out something out of all the terms? And on this one, there's not one. And then remember that this thing is being weird. Hold on. There it goes. Out front of x squared is a, and then out front of x is b. And the constant at the end is c. And remember to capture the sign with the letter. And in our star, we multiply a times c, put it in the top, b goes on the bottom, and a on the sides. So a times c for this one is 15, b is negative 8, and a, if there's nothing there, nothing shown, it's just a 1. Okay, now we look for numbers in these two side fractions. We look for numbers that, I'm kind of using this as a teaching reminder. So numbers that multiply to a times c, and at the same time, add to b. So in this case, we need numbers that multiply to make 15, positive 15, but add up to negative 8. So what would those be? Multiply to positive 15, add to negative 8. Negative 5 and negative 3. Okay, those multiply to positive 15 and add up to negative 8. Okay, and then we want to check if these can be reduced. Well, they already are, so there's nothing there to do. Okay, and then the top number goes with x. So this is 1x minus 5 from the left one. And from the right one, it's 1x minus 3. So that is factored form of that. This is called a quadratic trinomial, and it's factored form. Okay, so I see both of these in our list. So now we need to go factor the other one and see what matches there. And over here, again, we have a out front of x squared, b out front of x, and c by itself. Okay, there's no GCF, but definitely if a is not 1, you should check. 4 times negative 15, that's the top, so that's negative 16. The bottom is negative 17, and a is 4. Are there numbers that multiply to make negative 60 and add up to negative 17? Yeah, so in this case, it would be 3 and negative 20. Okay, so those multiply to make negative 60 and add up to negative 17. Okay, now we do need to reduce. This side is fine, and it becomes 4x plus 3. Remember, top number with x, bottom number just added in there. And then this one does need to be simplified first. So 4 goes into both, so we'll get 1 and negative 5. So that one becomes x minus 5. Okay, and the question says, which is a factor of both? So that one is a factor of both. Raise your hand if you got that one. Cool. Good job on your factoring. Okay, number 2, little review of, this is kind of, I must have moved stuff around. Number 2 is a review of parallel lines. So this symbol, remember, is supposed to tell us that these lines are parallel. And so what kind of angles are the two x ones? Those are corresponding, good, so we can set those equal. So 12x minus 10 equals 8x plus 18. Subtract your x, add your 10, and we get x equals 7. Okay, but that's not the answer. We need y. Again, this thing got shifted. It's annoying, but hey, I could move it. Sweet. It says find the value of y. So here's what I would do. 8 times 7 plus 18. That's just plugging 7 in to the x angle at the bottom. And then plus 9y minus 11 equals 180. What kind of angles are these two right here? They're a linear pair, right? They add up to 180. So we get 50, 8 times 7 is 56, plus 18, plus 9y minus 11. And let's see, 56 minus 11 is 45. 45 and 18 is 63. Subtract 63. And what is that, 117, I think? And divide by 9, what is that? Aldo's got it.
13.
Thanks. Cool. Raise your hand if you got that one. Okay. And finally, this is a simplifying radicals question. So this top one, if we split this into the square root of 16 times the square root of 2, and the bottom one is the square root of 16 times the square root of 3. So this is, remember, splitting things up into square rootable numbers. Well, our square root of 16 cancels, and we're just left with square root of 2 over square root of 3. The reason you don't see that answer choice is because we need to do what we call rationalize the denominator, and it's something we haven't talked about yet. Basically get rid of the square root in the denominator. So this is the square root of 6 over 3. So A. How many of you got to root 2 over root 3 at least? Okay. So we'll keep working on those square roots, the simplifying radical stuff. Cool. All right, good review to start. Let me fix this real quick. Why don't you grab your homework? We'll check it next. So we're going to start by checking number 2. That's a regular octagon. And so it has 8 sides. And I don't know if you can see this. That'll help maybe a little. Okay, so remember the interior sum is 180 times n minus 2. And so that's 180 times 8 minus 2. So the total inside is 1,080 degrees. And then we just divide it by the number of angles since it's marked as regular. So each angle is 135 degrees. All right, next one. Where do we go from there? I'll come back to 1. I know I signed that one. But did we go to 7 then? Okay. Number 7, what is the sum of the interior angles of an 11-sided polygon? Anybody remember the name of an 11-gon? Huh? We wrote it. It was the second to last one we wrote. Yeah, good job. Undecagon. Anyway, so 180 times 11 minus 2, and that's just 1620. So that was just the first equation that we did, that we wrote. Total of the interior. Number 8, now it's giving you the sum of the interior angles and asking you how many sides. So this time we plug in on the other side of our equation and solve for n. And we end up with 30 sides once we do that. Now, in this one, I distributed the 180 and then added 360 and divided by 180 at the end. We, in our example in the notes, divided by 180 first and then added 2. So either way is fine. Number 9, we're told each interior angle and asked how many sides this time. So this is the second formula we wrote down. And in this case, we were told the individual angle or each angle. So you plug in on the left, plug that 144. And then remember, we multiply by n on both sides and distribute the 180, get n by itself, and you'll end up with 10 sides on that one. Okay, number 10, how many degrees are in each interior angle? So that second formula that we wrote, only this time we're plugging in for the n instead of for each angle. So that's a more straightforward solution, and you end up with 108 degrees in each angle. Without 1, how'd you do on those other 5? Give me a thumb on the other 5. Okay. So 1, we'll do a few of these today, but mainly I want to talk about exterior angle sums. Here's the strategy on these kind. We need to know how many the total should add up to, and then we just add each angle to that total. So this is a hexagon. So I first found that the total interior angles in a hexagon is 720. And then you can see just x plus 120 plus 90 and like this whole line of work, and then set it equal to the total and solved. So on that one, if you tried it, you should have got x is 150. Did anybody get that one? Yeah? Okay. All right. Well, let's go do one of these in your notes. And they kind of look busy, but they're not super difficult. Here's a bunch of examples of them. Here's a couple more that look a little bit worse. If you look at that, it looks kind of yucky, right? But it's not too bad. In fact, if you focus in on the triangle, it gives you the kind of strategy that we are going to do. How many degrees are in a triangle? 180. And so we would just set those 3 equal to 180. So it's the same thing for something like this one. It's just that we don't know right off the top of our heads what the total is. So we have to find it first, and then we set all those things equal to the total. So let's do one that won't take you forever to write. Would you like one of these kind or just one of the regular ones? I kind of want to do this one on the right, this one. Okay. Just because I think it's a better example for, like, if you can do this one, you can do any of them, I think. So the directions will just say solve for x. So I'll give you a second to write that in. First thing I want you to do on these is find the total. So step 1, find the total. Angle measure. Based on the side lengths, based on sides. Okay, so this one is called what? Let me write that how we were doing it. What is the name of this shape? How many sides does it have? Has 6 sides, so it's called a hexagon. Yeah, there you go. Okay, so 6 minus 2 is 4 times 180. This is 720 degrees. So there are 720 total degrees inside there. Is it a regular polygon? No. Okay, number 2. Set the sum of all the angles equal to the total. And solve. Okay, the solving part is going to be usually pretty normal. So the sum of all these angles looks like this: 3x minus 20 plus 3x minus 20 plus 4x plus 3x minus 20 plus 3x minus 20 plus 4x equals 720. That's what we just calculated, that it should have a total of 720 degrees. Now, there are sometimes some shortcuts on this. For example, there are 4 3x minus 20s and 2 4x's. We could have used the distributive property and shortened this a little. I just wanted to make sure our concept is clear. Okay, now we just solve. Like from here, it's just solving. And I want to point out that we have lots of terms, so being organized can be helpful. For example, if I underline all the x terms, I probably won't miss them. So 3x is 6x, plus 4x is 10x, and then plus 3x is 13, another 3x is 16, and another 4 is 20. So we have 20x. And then all these numbers, let's use a different color. Negative 20 minus 20 is negative 40. Minus 20 is negative 60. Minus 20 is negative 80. Okay. Anyway, it just keeps you from missing a term, something like that. Okay, so we're just going to add the 80 over. So plus 80. And we'll get 20x equals 800. And so x equals 40. And then you probably should go back and make sure that makes sense. Like if I plug 40 right here by the 4, that angle says 160. Does that seem reasonable? Could that angle be 160? Yeah, I think so. All right, any questions on those kind? Okay. And just to remind you, so this one, same idea. I would definitely use distributive property here because there's 1, 2, 3, 4, 4x minus 80s, and 4 of these other ones. And that will shorten your work down a lot. These kinds, you don't always have that option. So you do just have to add up all those pieces around. But it's not hard, it's just making sure you keep track of the detail. So I'm going to let you work on that in a bit. I'd like to show you exterior angles real quick. And I say quick because it's pretty fast. And then we'll be done with polygon angles. So in your notes section, we'll just go ahead and write both of our exterior angle sums. So let's see, I think I'm gonna write over here interior, just to keep this somewhat organized. And then exterior. So we'll have 2 of these as well. And like I told you yesterday, these are way easier than the interior ones. So total or exterior sum, let's use the same kind of notation. The exterior sum, get this, it's always 360 degrees. No formula really there. It's just always equal to 360. And then each exterior, how would we do that, do you think? If all the angles add up to 360 every time, how do we figure out if it's like how do we figure out each exterior angle? How did we do it before for each interior? Right here. Didn't we just divide the total by the number of angles? Okay, same thing. Only this time the numerator is just always 360. So we just divide the total by the number of angles. Now what has to be true for that to work? Yeah, good job. If we're not told it's regular, then you can't do this. Same as before. And just to be clear, I'm going to try to draw one of these. Draw some kind of polygon. It doesn't have to be a regular one, but just sketch out a polygon, and we need to define what an exterior angle looks like. So an exterior angle is if we extend, actually let me use a different color. If we extend these lines so that they make angles outside of the polygon, so each of those are exterior angles. How many are there? 5 in this case. So the same as the interior, right? And last thing, I think we should probably say n is the number of sides / angles. Okay, so these you can see are easier. They always add up to 360, so you don't have to calculate how much they add up to. And as long as it's regular, we just divide by the number of sides to get the interior, or excuse me, to get each angle. So I think I'm not sure if it's needed to go do an example for this. Let's look at a few, but I don't know if we need them in our notes. These kind of look cool, like that one. When you take an octagon and extend all the sides, it looks, I don't know, it looks like something cool. I can't think of a name for it. Anybody? Yeah, there you go. You're right. Like the lens aperture maybe or something. Yeah. Okay, so here's an example of one. It says suppose angle 1 is congruent to angle 3. So that probably should be marked in there. And measure of angle 1 is 3x. So that means measure of angle 3 is 3x. Measure of angle 2 is 2x. What is the measure of each exterior angle? Tell me about what's going on down here. The two 90s are inside, but what can we do with them? Yeah, we can just copy them to the outside since those are linear pairs, okay? So here's how I would do this one. We know that all of the exterior angles add up to what? Yeah, so this is going to equal 360. I might note that this is not regular, so we cannot use the 360 divided by 5. This is a pentagon, we can't do that. So we're going to have to solve for it using the total of the exterior angles. Okay, then I would come in here and I would say, okay, this is just the total of each one. So 3x plus 2x. It's angle 1, 2, and then 3, 4, and 5. Okay, now we solve for x. We get 8x plus 180. And subtract your 180 to get 180. And what is 180 divided by 8? It's got to be some kind of 22.5. Okay. Okay, and then we just plug that back in. And so like angle 1 would be 3 times 22.5. So what is that, 67.5. Same with angle 3. Angle 2 would be 45. Okay, you just plug them back in. That's one example. Here's another version. just where we have to transfer the text into the problem. So look at your paper, the homework paper. And let me pull it up here. So problems like number 3 has exterior angles, number 5 also, number 6 does. So if you look at number 5, this has a mixture. So how do you know which one it is? Is it interior or exterior? Do you see how x is on the outside? That tells us we're solving for an exterior angle. So what are we going to do with the 145 and the 110? Well, not just move it. Is that what you said?
Yeah.
Like we can't just copy it over. But what is being formed right there? Yeah, that's a line, a linear pair. And so we just, to find this exterior angle, we can subtract 145 from 180. Same thing, to find this exterior angle, just subtract 110. And now you have all your exteriors, okay? And then you just use your exterior sum. So you'll finish the front page, which will be 3, 4, 5, 6. So go ahead and mark those, 3, 4, 5, 6. And then on the back, do the back, but cross off 13 and 16. Cross off 13 and 16. Otherwise, do the rest of both pages. So finish the sheet. And we do have some time, so go ahead and work till the bell.